2018 Section C Applied Graphics. We're going to look at geological geometry, okay? The accompanying map located at the back of the page, Section A, shows the ground contours at 5 metre vertical intervals. AD is the centre line of a proposed roadway. The motorway is widened between B and C to form a toll plaza as shown. The motorway has the following specifications. The portion from A to B is level at an altitude of 60, so from A to B is level at 60. From B to C is level and at an altitude of 65 meters as shown, and it is widened as shown. Perfect. So if B to C is level, that's fine. The portion from C to D is rising uniformly at a rate of 1 in 15. So that means for every 1 meter we go, or every 15 meters we go out, we go up 1 meter. Using side slopes of 1:1.5 for cuttings and 1:2 for embankments. Complete the earthworks necessary to accommodate the motorway between A to D and on the north side. You may ignore the southern sides. We only have to do it up the top here, okay? So, cut and fill is there. So, our cut is, we're going up 5. So, every 5 we go up, we're going out 7.5. So, 1 is 1.5. And embankments 1 is 2. So, every 5 we go up, we're going out 10. Okay? So, it's all level from A to C. Okay, so that means all our lines, cut lines, are going to be horizontal to the road, or parallel to the road the whole way along. So it's going at 65. So it's going 50 to 65 here. So that means that we're going to have to fill in the section of the road here because it's lower. The groundwork is lower than the road, so we need to fill it in. So it's going to be embankment. So we're going up 5. Every 5 we go up, we're going out 10. So we're going to go out here 10. Okay. So our road is at 65. So this is going to be 60, 55, 50. There's we lost 60, 55, 50. Okay. So we've got our 50 out here, 50 here, 55, 60, 65 on the corner. Perfect. And that drains up there. It goes out there. Okay. It's the same this way. Only this time here, we're going into 70, 75, 80. So this is all going to be cut. So our cut is going to be at 7.5. So we want to measure out 7.5. 5, 15, 7.5, 15. Okay. So split this up then. 65, 70, 75, 80. So 60 by 70, 75, 80. So that's 65 there, 70 is here, 75, 80. And just to continue that off out there. Probably never make it there. Okay. It's the same one across this way here then. So you split it up again. $65, 70, 75, 80, 85, 90, 95. Goes up to 100 here. 100. Level these then. So 65, 70, 75, 80, 85, 90, 95, 100. So I need to continue these 70 lines out a bit further here to get where they cross. So I'll do this section here. It's going to continue out there, that's fine. 70 is out here. 75. 80 is going up there. I need to continue a bit further. 80. Sorry. This is 75 here, so sorry, that's 75. This is 70. 5. 80 is here. 80 is here again. 75. 75. 80, 85, 90, 95, 100, 100. Okay, so curves here like this. Okay. And where they cross over here, then that comes back to a corner of our road there. Okay, that's that section there. Again, it's the same over here then at the angle. So we're gonna go 15 again, road 7.5, sorry. It's going to be 70, 75. So this is all cut because we know the road is lower than the ground. So 65, 70, 75, 80, 85, 90, 95. So where's my road starting here now? So 70 there. Need to go another 7.5. That's 100 there. That's 100 there. 95, 90, 85, 80, 75, 75, 80, and 80. So they can all be linked up then. Okay, and where these two cross then, comes back down there, gives me my road. Okay, now that's all that section there done. That's level. Okay, now what we need to do is we need to set up our cones here now for our cut and our fill. So for every 15 we go up, we're going up 1. Now I don't have 15 mil out here, but I do, so I cut that in half. So I'm going to go out 7.5. And measure there. The rod is rising, isn't it? 115. So every 15 meters we go out, it goes up 1. So it's 65 there currently. And at this point now, it's going to be 65.5. That's the height of my roadway there. That. Okay, so I can now half. If I had to go 15, I'd be able to go up 1. So 65.5. So now here, at this section here, we're still cutting. Okay, so we need to set up a cut cone here. So I need to set up my cone. It's going up. My cone is, it's a cut cone, so it's 5, so it's 7.5. So I'm going to set up my cone here. With a radius of 7.5. It's tricky enough here. Okay, and that's then going to join back to so if I'm going cut, I'm going back away from where I'm coming from. Okay. So what I can do now is I can now just step out all my 7.5s flat there. Sorry, parallel to that. So this is 65 in here. So this So this is 65 in here. So this is 70, 75, 80. Do I need to go any higher than that? No. Okay. So 80 cuts this line here. And it cuts it here. 75. 70 doesn't cut my walls. I need to come in. I need to bring in 7.5 this way. Down here so it gets to 65. And I can join that up there. Now where the two of them cross again, joins back in there. That's another split there. Okay, now that's all cut there. Now this side is fill, so we're doing the opposite this time. So our fill cone is larger than that. It's going to be 10 mil. Radius 10 mil. It's going up 5, it's going out 10, yeah. And again, we draw our slope line to there. And we're going up in spaces of 10. 10, 20, 30. There's not much there. Again, this line here is at 65. So we're going parallel to that, 65, 60, 55. Now we need a 10 mil come back in this way, we're going to have to give us a 70. Okay, so that's 70, 65, 60, 55, 55, 60, 65. Okay. And that's that part of the question then done. Put in our tadpoles always swim towards the highest part, so that's the highest part there. High that way, 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 low here, and low here. Okay, so that's part A, section A, that's question part A of the question done. Part B here then is on the map, P, Q and R are 3 points on the surface of the Earth. Vertical boreholes at these 3 points reveal a triangle on the top surface of the stratum of ore at altitudes of 45 meters, 60 meters and 35 respectively. In the space provided at the top of the map, draw the elevation of the triangular portion of the top surface of the stratum. Okay, so we'll start by doing that there. So we'll take point P, Q and R, bring them straight up. What's the test is drawn? Point P is at, R is at 35. And we're going to bring these up here. So we're going to draw the road right, or the contours right in 5 mil intervals. So we mark up all our 5 mil. Draw these across here. Um, 45 is P, so that's 35, 40, 45. And 50, 60 is Q, so there's 45, 50, 55, 60. Draw the plan of the triangle and determine the strike and dip of the stratum. Okay, so drawing our plan here. Right, so how do we determine the dip and the strike? What we need to do is we need to get a true length line. So come across here from P, Q, and R. Come across from P in elevation. We get a straight line where this hits QR, bring it straight down. Where that hits QR there in plan gives me true length line. I'm going to look up along that true length line. And I'm going to set up an auxiliary view. Project up R. Project up Q. R here is at 35. Take your heights up here, so that's going to be up 10 mil for P. And it's going to be up 5, 10, 15, 20, 25 for Q. Join them straight up. Here's my dip there. My strike then is the angle that this line makes here. That this my true length line makes with the north line. So get your protractor there. Measure this angle here. My protractor doesn't cover it, so I just have to extend it down a bit further. So it's 125 degrees. Strike. 125 degrees. And what direction is it going? This is north, so it's going southwest. Okay, part 3. Determine and indicate in meters the length of the shortest skewer borehole from R to the top surface of the stratum. From R. Right, so determine and indicate in meters the length of the shortest skewer borehole from R to the top surface of the stratum. Okay. So from here, like this across here. And then we're going to take the distance between R and our strike here, which in this case is 8 mil. Bring your 8 mil up past here. Set up then perpendicular to our line here. And bring it back in here. So that's our distance there. Okay. That gives the distance. Part C, determine in plan the line of intersection between the top surface of the stratum and the surface of the widened portion of the toll plaza. Okay, so all I look for there is where is the widened portion going to hit that. So if we, that's our 35 there, that's our 60 height up here. If I measure above my 60 height here of 5 mil, extend that out past that, extend my line up to where it hits the road. So this is my stratum here coming up to intersect the road. It intersects the road there. And all I'm doing then is just bringing that point back in here to where it hits the widened section of the road. So that's where the stratum cuts it along there. Okay. Any questions in relation to that one? Let me know and I'll do my best to answer them.